Hi there, welcome to the fourth video on the function and graph topic, looking at exponential and logarithmic functions. Okay, so there's 5 things you want to be able to do from this video. Firstly, being able to draw the graph of a given exponential function, identify the function from a graph, understand that logarithmic and exponentials are inverses of each other, and then be able to draw the graph and identify the function of a logarithmic function. Okay, now exponential you'll have heard before in reference to growth or decay. Mainly now, the big one would be like a zombie plague would be a kind of favourite example there, like how it starts off with one person, your patient 0, and it gets bigger and bigger, faster and faster. The rate of infection rises exponentially. Now, what that means is it gets bigger and bigger, faster and faster. Okay, now an exponential function is one where your x value is part of your power. Okay, so you can see here, your x value is part of the power in the function f of x equals 2 to the power x. Now, to see what's happening in the graph, we're going to look at just a small table of values here. So if f of x equal to 2 to the power x, and I give you the x values minus 2 up to 4, can you find out for me what's happening to your f of x values, to your y values? Okay, take a wee second to do that. Okay, so I'm going to start here at the power 1, just to kind of the nice easy powers first. So 2 to the power 1, we know is going to be 2. 2 to the power 2 is 2 squared, 4. 2 cubed is 8, and 2 to the power 4 is 16. Okay, so you can see there that it is getting bigger and bigger, faster and faster. If you think about the next one, would be 32, then 64, then 128. It would just keep going up more and more each time. Okay, now if x is 0, we're doing 2 to the power 0, which we know is 1. Okay, 2 to the power negative 1, remember your negative power would go to the bottom and go to your denominator. So that's going to be 1 over 2 to the power 1, so just 1 over 2. Okay, and then negative 2 will be 1 over 2 squared, so 1 over 4. Okay, a couple of things to note here. That 2, okay, that there, if we're looking at this in the term of a to the power x, it doesn't matter what that a is here. In this case, it's 2. If it was 5, if it was 10, 1 point in there would always be the same. Okay, and that's the 0.01. Okay, because regardless of what that a is, your power 0 is always going to be a 1. Okay, there is also one other one here. That 0.12, because that x is 1, is just going to leave you whatever a is. Okay, so 2 to the power x will leave you 2, 5 to the power x will leave you a 5. Okay, the other thing to notice is as you go further and further down the way, okay, you're going to a quarter, an 8th, a 16th, a 32th, a 64th, and so on and so on. You're never ever going to reach 0. Okay, so as long as a is bigger than 0, you're never ever going to reach 0. Okay, so that leads us to this exponential graph. Okay, and I'm just going to give you one that I've drawn already. Okay, so there's your exponential graph. We know that it never hits 0 going that way. It goes through the 0.01, regardless of what graph it is, and it goes through the 0.12. Okay, now obviously it goes through a lot of other points, but these are the main ones, and these are the ones you need to know. Okay, going through 0, 1, going through 1, 2, or whatever the number is, and it never ever touches 0 going to the left. Okay, so that is your graph of the form f of x equals a to the power x. 0, 1, 1a, never hitting 0. The only thing we need to be aware as well, though, is if that a is less than 1, so this is where a is bigger than 1. Okay, if a is less than 1, okay, that means as your power goes up, like you get more halves, you're getting smaller and smaller and bigger and bigger, so it's like a reflection. Okay, but again, it still goes through 1 and the 0.1a. Okay, so from that, I'm going to give you a couple of questions to look at. Okay, firstly, I'd like you to sketch a graph of fx equals 6 to the power x. Give the video a pause and give that a bash. Okay, so nice and easy. This is just something you need to remember. Okay, I'm going to try and make this as neat as I can. You know the shape of the graph because x is in the power. You know it goes through 2.01 and 1, 6. Okay, job done. Easy as that. Okay, 2 examples there to try. Okay, I'm giving you 2 graphs. I want you to tell me what the graphs are. Okay, so first one there, you can see from that point 1, 8, we know this has to be f of x equals 8 to the power x. Okay, nice and easy. Second one, a little bit trickier, okay, because we've not been given the value where x is 1. Okay, but what we can do, same as we can do with any point, is take out an x and a y value and substitute it into the function. So 125 is equal to a to the power 3, and we should be able to see, or we can do the cubed root, that a is 5. So f of x is equal to 5 to the power x. Okay, not much going on with this. We'll do some transformations in an upcoming video, or transformation we do in an upcoming video could apply to these as well, but this is literally just about knowing your basic graphs. Okay, now the inverse function of y equals a to the power x. Okay, I'll just use a y there. Y equals a to the power x. The inverse function is this logarithmic function. Okay, so up here in your y equals a to the power x is your power, it gives you an answer. For the inverse, you are using the answer to get the power. Logarithms give you the power. Okay, we also know, and again, I'll just keep drawing these on, 1 and 1a. Because the inverse function flips these over, it's now going to be 1, 0, and a 1 on your logarithmic graph. Okay, and again, as you go further down in here, it's never ever going to hit the 0, but this time it's a 0 on the y-axis. Okay, your x being 0. Okay, so there is your graph. Okay, 1 and a1. And again, it's just something you need to remember. Okay, you need to remember what a logarithmic graph looks like. You need to remember those 2 points. Okay, again, I'm going to give you a couple of questions, let you give them a try, and then I'll go over them. Okay, so firstly, can you sketch a graph of f of x equals log x to the base 4? Okay, and that's how you say it, log x to the base 4. Okay, pause it and give it a try. Okay, so again, nice and easy, just remembering the shape, which we know looks like that, and the fact that it goes through 1 and a1. Oh, rubbish. What have I done? Not a1 specifically here. A is 4, so it's going through 4, 1. Okay, apologies. Okay, that is a graph of y equals log x to the base 4, or y equals f of x to the base 4. Okay, this one here, identify the functions of the form y equal, sorry, give me 2 seconds, I'm just going to fix it. Okay, apologies, I got a nightmare on a couple there. Okay, so identify the function of the form f of x equals log x to the base a. Okay, now we can see there, because it goes through the point 10, 1, a has to be 10. Okay, log x to the base 10. Okay, and that's it. Okay, so 5 things you're able to do. Draw the graph of an exponential function, identify the function from the graph, understand that logarithms and exponentials are the inverses of each other, draw the graph of a logarithm, and identify a logarithm from a graph. Okay, you'll do much more work on logarithms, especially in the logs topic later on. Okay, but right now this is what we need to do. Okay,